Okay, hello. Let's look at question 6 from your 2020 question paper, this one that we did at the end of August. It says question 6, simplify as far as possible. So if we look at 6.1 and 6.2, as you can see, there's no equal sign anywhere. So if there's no equal sign, it's an expression. So now when you see an expression, we can't get an answer to say x equals 5 or x equals 2 or x equals some other number. With expressions, our job is to make it have as few terms as possible. Now remember, terms are separated by a plus and a minus. So we're going to treat these like we would any sum with numbers, and we're going to look at BODMAS, okay? Because what you do with numbers, you do with the variables in expressions. So if we have a look over here, can you see I have some brackets, okay? So if these were numbers like 5 minus 6 or something, we would have to solve these brackets first. But because we don't know what this x is, we can't actually solve it. So now we need to think, how can we get rid of this bracket? What is this bracket doing here? So if we have a look here, what you will find is that this bracket is touching the 3x squared. Now you know if a bracket is touching a number, it means that you must multiply, okay? Remember, there's different ways of showing multiply. There's the multiply sign, there's the dot, and there's also when you put the number next to the brackets. So here we've got a number next to the brackets. So that means everything inside the bracket is multiplied by everything outside the bracket. So the first thing we want to do is multiply the 3x squared times 2x. So in fact, every time we do an expression, the first thing we want to do is write out the whole expression. So we write out the whole expression, 6x cubed plus 3x squared bracket 2x minus 1. So as we're writing this out, we can immediately see that the 3x squared is actually touching the bracket. So we know that they must multiply like we showed with this little arrow over here. So we aren't doing anything to the 6x cubed first, because remember BODMAS, we can't do any adding before we do multiplying, okay? So now we're going to multiply, like I showed you in green over there, 3x squared times 2x squared. So 3 times 2 is 6, and x squared times x gives you x cubed. Remember, when you're multiplying x's or you're multiplying variables, you use the exponent laws. So x squared is x times x, and so if we have x squared times another x, it's x squared times x gives you x cubed. Now we've sorted out the first term in the bracket. We need to sort out the second term here, because when it's touching the bracket, it's multiplying everything in the bracket. So now I've got 3x squared multiplied by negative 1. So we know that any number multiplied by 1 is itself. So here, itself means the same number. So it's 3x squared times 1 would be 3x squared. But look, I've got a plus and a minus, and a plus multiplying a minus gives you a minus, okay? So now we want to carry on with our BODMAS here, okay? We got rid of the bracket because B stands for bracket. Are there any exponent things we can do, like exponent multiplication? No, we can't. So we've got brackets, the O or the E for exponents. If you say BODMAS, we've got divide. We don't have a dividing here. We don't have multiplying, so we're left with add and subtract. And BODMAS says if you add and subtract, you work from left to right. But we also need to remember here that we are working with like terms. So how do you know when a term is a like term? It must have the same variable. Okay, so check these are all x's. But it must also have the same exponent. So can you see this one has got an exponent of 3 and this one has got an exponent of 3. So they are like terms. But the last term, can you see, it has an exponent of 2. So we can't use the last term, but we can use the first two terms. So we've got 6x cubed plus 6x cubed. So this would be 6 dinosaur eggs plus another 6 dinosaur eggs gives me 12x cubed. Okay, so if I'm adding dinosaur eggs, they must still end up as dinosaur eggs, x cubed. And then I can't do anything with this 3x squared because it is now my it's in its simplest form, this expression. Remember that if there were substitution, you could find an answer, or if there were equals, you could find an answer for x. But we don't have either of those, so we have to stop here. This is our final answer because these two are not like terms and we are adding and subtracting, so we stop here. Now let's have a look at this next one here. It says simplify as far as possible. So again, we aren't substituting, so I can't get rid of the x. We aren't putting in an equal sign, so I can't solve for x. So my job here is to simplify by making few terms. So to do this, we must find like terms. So the first thing we see here is a number. This number does not have any variable with it, so it must be a constant. The next one says minus 4x. That's got a variable, so it's not a constant. Let's look and see if there's any other constants. This one says plus 5x squared. It's got a variable. It can't belong with the constants. This one says subtract 6. Okay, so this one does not have a variable. It belongs with the 3 because they are both numbers. They are both constants. Plus 7x doesn't belong because it's got a variable. Minus 8x squared doesn't belong because it's got a variable. Then if we look at the next one along here, I now have negative 4x. Now remember, when we do this, we are supposed to pick up the sign, the coefficient, and the variable. So the sign is minus, the coefficient is 4, and the variable is x. Okay, so let's look at the next one. It says plus 5x squared. Now there's an x, but it's squared, and like terms must have the same power, so I'm going to ignore this fellow. Let's go on. The minus 6 belongs with the 3. Now I've got plus 7x, okay, because we need the sign, the coefficient, and the variable. So this one is fine to belong with the negative 4x because it's also only got x, not x squared, and the last one is x squared, so it doesn't belong. So now I'm left with this term, plus 5x squared, okay, and he's got an x squared, so he belongs with the other x squared. So can you see in blue I have my constants, in green I have my terms that have x to the power 1 or just plain x, and in yellow I have my x squareds. And every time we pack up the sign, the variable, and the coefficient. So now I want to put the 3, and I must put with it the minus 6, okay, and then I do my green ones, minus 4x plus 7x, and I'm packing up the sign, the coefficient, and the variable. And then I do the yellow ones, which are the x squareds, 5x squared subtract 8x squared. Okay, now remember what I said. Sometimes we think of this as negative 4x, and sometimes we think of it as minus 4x. But if you pick it up the variable, you must pick up the sign, the coefficient, and the variable. Now we have a look here, and we say 3 minus 6. These are integers, people. Draw a number line if you're not sure. We went from positive 3, and we took 6 away. We will be left with negative 3. Then we look at the next two like terms, these ones that were in green. We have negative 4 eggs, and we add 7 eggs. So if we were missing 4 eggs and we added 7, we would end up with plus 3 eggs. Okay, and now here we've got bigger x's. These x's or eggs must be maybe an ostrich egg. Yes, if we had dinosaur eggs in 6.1, these are ostrich eggs because they like x, but they're bigger. Okay, so I've got plus 5, and I subtract 8. So I must have negative 3x squared. Now, you can leave your answer there. I cannot simplify this any further in grade 8 because we don't have any more like terms. Check, this one is a constant, this one has x, and this one has x squared. They are not like terms because they don't have the same variable and power. So I can leave the answer like this, but remember your maths manners. In algebra, we're always supposed to put the biggest power of x first. So we should pick up the sign, the coefficient, and the variable, and we should write it like this. Okay, because this is now descending powers of x, and that would be your final answer.